Okay, so in 5.4 we did inequalities in one triangle. 5.6 we've now got two triangles. Okay, and even though it's not there in the vocabulary, the hinge theorem, it's not used very often anymore, but occasionally it is. And a car jack, as you can see in the diagram here, is a perfect example. All right, a car jack, when it's fully closed properly, then angle A becomes acute. In fact, it will be virtually flat when it's compacted down completely, but the more that you lift it and raise the car, angle A gets smaller and smaller. Well, looking at the relationship, we already know BC here is quite long, but by the time you've got a jack that's been lifted up, it's got quite small. So there's where you can find the inequalities between one triangle and another. Here's where you see the hinge theory to make two triangles with inequality. If you look at what you've got here, you've actually got two congruent sides with this triangle here, but because angle A in this guy is greater than angle F here, then all we're looking at now is BC must be greater in length than GH. Okay, so this is comparing given measures. Okay, if we look at these two triangles, this guy here has got 55, this has got 51. All right, so you know by definition that this side is going to be greater than this side. All right, be careful also with the type of questions, because look what we've got here. Okay, by the converse. In other words, in question A, you were given the angles and you had to find the sides. In question B, you've got the sides, so you need to find the angles. Well, what do you know? That the sides opposite the angles must be different in size. So that's the converse of the hinge theorem. Okay, so what we got here, this is question number 1. It's talking about ACB. So ACB is this angle here, or angle C, and GDE, which is this angle, or angle D. Okay, well now let's have a look at the opposite sides. Well, opposite this guy is 3.2 and opposite this guy is 3. So you know that this is the greater sized side, so C must be the greater angle, or ACB. So comparing it, the measure of angle ACB is greater than the measure of angle GDE. Okay, so here's the hinge theorem in its entirety. It's given you all this information. You've got to prove that DE, in other words, this side here, is greater than AB. Well, all you have to do basically is look at the angles. Is angle C greater or smaller than F? You know it is, so you know that DE is obviously greater than AB by the hinge theorem. But the proof lies in that you've got to do it by, don't forget we're looking at those again, side angle side, and don't forget your corresponding parts of congruent triangles are congruent. You'll see that so many times. So let's have a look at question 5. Okay, two children on swings in the park maybe. The position of the swing changes based on how hard the swing is pushed, the position of each particular child. Well, let's have a look at what it's asking you first. Which are the pairs of congruent angles or sides? Okay, well, the first obvious one is from the top of the swing frame to the ground. So obviously we know that AB is congruent to DE. That one's pretty simple. The second one's depending on to make sure that the children are the same size in height. Well, if they're the same size in height, then AC must be congruent to DF. The distance from the frame to the child should be the same. Okay, so now let's have a look at B. Is the measure of A or the measure of D greater? Okay, Well, obviously in the second one here, this child's swinging out much further, so this angle will be greater than this. So you can turn around and say that angle D is greater than angle A. Okay, and in the example, let's have a look at what you've got. Well, let's have a look. For a start, it gives you all this information. All right, but it does tell you that this and this are the two sides. Well, you know in relative shape to each other that the 6x plus 5 must be greater than the 15, which is what you've got here. Then just solve it to make sure that x is greater than 8 1/3. And as you can see with step 2, what we're looking at now really is basic algebra. But if you look, it's asking that it's saying that JHE must be less than 180 because that's the amount that's in a triangle. Set them in theory equal to each other but an inequality form and solve again. Okay, so you know from step 1 that x is greater than 8 1/3, and from step 2 x is less than 27.5. So put it into a compound inequality. Okay, so what do we know? Well, we know that 57 is greater than 41, so 12 must be greater than 3x minus 6. So let's put that in an inequality. So 3x minus 6 must be less than 12. Use your basic theorems of algebra in order to solve the inequality. So add 6 to both sides. So 3x must be greater than 18. Divide through by 3, so x must be greater than 6. There's one part of your inequality. What's the second part? Well, the second part is the fact that 3x minus 6 is a side, and sides must be in the positive, so it must be greater than 0. Okay, so this guy must be greater than 0. Again, using algebra, the theorems of algebra to solve an inequality, add 6 to both sides, so 3x must be greater than 6. Divide through by 3, so x must be greater than 2. Okay, so let's put these two guys together. So x is greater than 2 but less than 6. So 2x is greater than 2 but less than 6. And there is your compound solution. Okay, now we're back to what students hate, proving the relationships. Well, here's the hinge, here's proving triangle relationships using the hinge theorem and writing a 2-column proof. Okay, we've got the given. We know we need to finish up with the hinge theorem. So look for properties. So AE, if you look at it, is on both this triangle and this. So you've got the reflective property, the number of times that comes into play. We know that two angles must add together to make the other one. So you've got angle addition, and we want one to be bigger than the other. So we've got a definition of inequality. And obviously this is the same thing using the converse of the hinge theorem. All right, this is a flow proof, or a flow chart, it doesn't matter. But again, start off with whatever is given, finish up with what you need to prove. Okay, as usual, always start with the given. So here's your given statement. So that's your first column. So here's your statements and reasons. So that's your given. Okay, where do we go from that? The reflect that WZ is needed for both of them. So WZ is congruent to ZW because it's being used in both. And there's the reflective yet again. Get used to seeing that one, it's a must. Okay, what else do we know? Well, according to what we're after, angle 1 is actually an exterior of y and 2. So we've got the definition of an exterior angle. So angle 1 is the definition of an exterior angle. Okay, and how do we finish up? Well, we know that angle 1, it must be greater, the measure of angle 1 must be greater, that must be greater than the measure of angle 2. Okay, and that's as far as we need to know, but that's that's one thing. That's the remote angle theorem, remember that. And then finally we've got a last one to come on. How are you going to prove it? Well, this is a side angle side inequality. Okay, and what do you know?